In this video, let us discuss about measures of central tendency. Let us understand what is the meaning of measures of central tendency. A central tendency or average is a single figure which represents the entire data. So it's the definition. A central tendency or average is a single value which represents the entire data. We can also say that central tendency indicates where the center of the distribution tends to be. According to Cropstone and Cowden, an average is a single value within the range of the data that is used to represent all values in the series. Since an average is somewhere within the range of data, it is sometimes called a measure of central tendency. So look at these values. So we have got here 2, 4, 6 and 8. So when we calculate the average, so we simple method of calculating the average, as we know, it is add all the data. So 2, 4 plus 6 plus 8 divided by number of data. So we have got here 4 data. So therefore 2 plus 4 plus 6 plus 8 divided by 4. So we would get it as equal to 5. So here 5 is the representative of all these data set. So what are the functions of the central tendency? So central tendency would give us the brief description of data. As we saw here, 2, 4, 6, 8. So this 5 is the representative figure which represents all these data set. So hence here we can say that the central tendency would give the brief description of data, and it is helpful in forming the policies. And with the help of this calculation of central tendency, one can do the statistical analysis. So what I mean by saying brief description of data is, so it presents simple and systematic representation of the raw data. So we can see that. So we had a figure data set 2, 4, 6, 8. So it's a big description. We can only say we have got a data set 2, 4, 6, 8. Instead of that, if I calculate the average, it comes as equal to 5. So 2, 4, 6, 8. 2 plus 4 plus 6 plus 8 divided by 4, as we have got 4 data sets. So we would be getting it as equal to 20 by 4, which would be equal to 5. So 5 is the representative figure of the data set. So hence it's simple and systematic description of the raw data. So average reduces the mass data into single figure. As we saw here, we have got 4 data, but that is reduced to a single figure. So hence average reduces the mass data into single figure. So here I had got only 4 data points, but think, when nowadays we are thinking about big data, when we have got a big data, so a single figure would represent the entire data set. So that is the advantage of finding the average. And also one can draw conclusion about the whole raw data by just a single figure. So that is all the advantages of finding the average. And then it is helpful in making the comparison. So average is very much helpful in comparing the data set. For example, average income, we would have calculated the average income in the one state, let us call it as XYZ state, and then another state as PQR state. We can calculate the average income, and then we can say that we can make the comparison so that people would invest their business where the income, average income is more. Similarly, if suppose you took a test and then you got 94%. You might have done exceptionally well or may not. Perhaps the test was really easy. or you are really smart. If I tell you the raw score of your class is 84%, 90%, 70%, 95%, and go on like this, you still do not know how much you are, how you cannot compare. Instead, if I say you the class average is 80.5 and you have scored 94%, then you know how you have done the test. You can analyze that you have done the test very well. So that is how the average helps in comparison. Average, as I discussed, average also helps in making the policies. On the basis of average figure, government of any country can formulate the policies. For example, when government of India finds per capita income in India is very low, it can formulate suitable policies to improve the standard of people, like creating a job, providing policies on financial schemes, giving subsidies. So these are the ways government can think of to increase the per capita income. So this is how the average helps in making the policies. And as I told, average also helps in making the statistical analysis. As we can see here the y-axis represents the number of items sold and x-axis on different days of the week. So Monday we can see 250 items sold, Tuesday we can see 150 items sold, and Wednesday 75, and Thursday 125 items sold, and Friday 100 items sold, on Saturday 200 items sold, and on Sunday 300 items are sold. So one can analyze the pattern of the data here. So we can see that during the weekdays there is less items are sold compared to the weekends. So in this case, company should think about increasing their items sold during the weekdays. For that, they need to figure out different ways how they can increase the sales on the weekdays also, so that their business would improve. So this is how one can make the analysis by finding the average. So there are different methods of finding the average, or the different methods of finding the central tendency. So here mainly I'm discussing only on the mean, but there are different types of central tendencies are mean, median, mode, normally considered are studied by the people, and which are the easy means. And along with this, one can also adopt harmonic mean and the geometric mean to find the central tendency value. So let us discuss the first method, that is the arithmetic mean. So arithmetic mean is denoted by X bar, and it is the most common measures of central tendency. So mean is the most common method of central tendency. And then if we have got a raw data, or we also call it as an individual series, or if the number of data are small, less, then we can write the formula for arithmetic mean as X bar is equal to total of X divided by N. So here X1, X2, etc. Xn are the N values, are the N data sets. So divided by total number of data would give us the arithmetic mean. This is the direct method. So in this video, I am only discussing the direct method of finding the arithmetic mean. So for example, here the table below shows the number of sales of 5 retail outlets in a day. So retailer 1 has made a sales of rupees 8,000, and the retailer 2 had made sales of rupees 23,000, and the retailer 3 has made a sale of rupees 4,000, and the fourth retailer has made the sale rupees 8,000, and the fifth retail has made the sales 2,000. So we want to find the average sales. So hence we will adopt the simplest way of finding the arithmetic mean. So what you say, sum all the observation, divide by number of observation. So when we sum it, so we have got 8 plus 23 plus 4 plus 8 plus 2 divided by, we have got 5 retail outlets. So therefore divided by 5. So which would give as 45 by 5, which would be equal to 9. That means the average sales per retailer can be taken as rupees 9,000. So this is the arithmetic mean calculation or the average calculation for the raw data. Let us consider one more example. So hourly production of a manufacturing plant for 8 hours is 1,200, 1,190, 1,210, 1,180, 1,190, 1,220, 1,230 and 1,180. So these are the data taken for the hourly production of a manufacturing plant. So then we want to calculate the average production per hour. So then we would, as the formula says, X bar is nothing but the average arithmetic mean. So which can be written as sum of all the data divided by total number of data. So we add all the hourly production, the total hour production, we get it as 9,600 divided by, for 8 hours we have taken the data. So therefore divided by 8, we would get it as 1,200 hour. That means the average production is 1,200. This is the average production of the manufacturing plant. So here again, the example 3 would quote, we want to find the mean driving speed or the average driving speed for 6 different cars on the same highway. So on the same highway, we have taken the speed of the 6 different cars, and then we want to find the average speed. So mean driving speed. So as these are the raw data, so as the formula says, add all the data divided by the total number of data would give us the average driving speed. So here the average driving speed is 62.5 mile per hour. So this is how we can calculate the average or the arithmetic mean for the raw data. So sometimes we may be knowing the average or the arithmetic mean, and due to some condition we might have missed the some 1 or 2 data, but still we can get that, we can guess or we can find out what is that missing data. So in this example, so we know that arithmetic mean of 14 observations. So there are 14 observations and the arithmetic mean of these 14 observation is 17. But we do not know, here one data is missing. So we do not know what is this data represents. So that can also be calculated. How do we calculate that? So we follow the same method. We know that arithmetic mean can be written as sum of the observation divided by total number of observation. So in this problem, we already know the arithmetic mean. The arithmetic mean is 17. The average we know already, it is 17. So according to the formula, arithmetic mean is equal to sum of the observation. So except X, if you add all the data, it will come as 216. So therefore total will be 216 plus X divided by, we have got 14 observation. So divided by 14, then by cross multiplying. So we will get 17 into 14 is equal to 216 plus X. So then we can solve for x. And when we solve for x, we get x as equal to 22. So here the missing observation, the missing data is 22. So this is how we can also find out if any data is missing. We can, if we know the average, we can calculate the value of that particular data. So now let us see if you have got a discrete observation. We have got more number of data, repeating data. So when this discrete series comes, suppose if I have the first, suppose let me take the marks scored by the students out of 10. Suppose out of 10, I have got 5 students who scored 10 marks. So 10, 10, 10, 10. So it is 5 students who has got 10 marks. Let us assume 5 students have got 10 out of 10. We have taken a test out of 10 and then let us think that 5 students have scored 10 out of 10. Then the next score, let me take it as 9. 9 is scored by 3 students. And let us assume the next number 8. 8 is scored by 2 students. And let us take the next number 7. 7 is scored by only 1 student. And suppose 6 is scored by 4 students. So like that, if I have a data set and then if I want to calculate the average, then it becomes like I need to add 10 plus 10 plus 10 5 times, 9 plus 9 plus 9 3 times, 8 plus 8 2 times, then 7, then 6 plus 6 plus 6 plus 6. So this would become a tedious task. In order to make the calculation simpler, we can put it under the discrete series. How do we put it? So x is the marks here and f is the repetition. How many times it has repeated. So I can put here 10 is the marks and it is repeated 5 times. And then 9 is the second marks. And then it is repeated 3 times and 8 is the coming next marks, so which is repeated 2 times and 7 is repeated only 1 time and 6 is repeated 4 times. So we know mathematically 6 plus 6 plus 6 plus 6, instead of adding like this is equivalent to add 4 into 6. So that is what. So if you have got like this kind of data which repeats many number of times, so such type of data can be put under the discrete observation. So in that case, our average would be x bar would be equal to f1 x1 plus f2 x2 plus etc. fn xn divided by f1 plus f2 plus etc. fn. That is nothing but the total number of data. So this is the formula. Total of fx divided by n would give us the average for the discrete observation. Let us understand this with the help of a problem. So here is a problem. The students in a statistics class were trying to study the heights of participants in sports meet. They collected the height of 20 participants as displayed in the table. Calculate the mean height of the participants. We want to calculate here the average height. So here one participant is having the height as 49 inches. 2 participants are having the height as 53 inches and 4 participants are having the height as 54 inches and 5 participants are having the height as 55 inches, and the data you can read like this. So now as I discussed, so this data comes under the discrete observation because we have got a frequency here, how many times a data would repeat. So in that case, the formula for the average is x bar is equal to total of f into x divided by n. So we can construct a column, we can prepare a column height and then the number of participants under the frequency, and then you can multiply f into x. So 49 into 1 will be 49, 53 into 2, 106. So like that we can multiply the data. So f into x and then take total of all the data f into x, total it. So you would get it as 1200 divided by n represents the number of data, how many data we have taken. So here we have taken 20 participants, therefore divided by 20. So if in the question we are not given the total number of data, in that case you need to add from the f column, from the frequency column. If you add, you would get the total number of data. So then divide that 1200 total divided by the number of data taken. So in this problem, it is 1200 divided by 20. So you would get it as 60. So therefore, the mean height. So even though we have got 20 students, the mean height, the average height is equal to 60 inches. So here is one more problem. A proofread through 73 pages manuscript. The number of mistakes found on each of the pages are summarized in the table below. So these are the number of mistakes in the pages. So we want to calculate the average mistake found per page. We want to calculate the average mistakes found per page. So here 5 pages are having only one mistake and 9 pages are having 2 mistakes. 12 pages are having 3 mistakes. 17 pages are having 4 mistakes. 14 pages are having 5 mistakes and 10 pages are having 6 mistakes and 6 pages are having 7 mistakes. So totally we have got 73 pages in the manuscripts, and these are the mistakes, number of mistakes in the pages. We want to calculate the average mistake. So as again this comes in the discrete observation, we have got the mistakes can be represented as x, and the number of times the mistake repeats can be considered as f, that comes under the frequency column. And as we know that average can be calculated as total of f into x divided by n. So let us construct a column for f into x. So 1 into 5, 5, 2 into 9, 18, 3 into 12, 36. Like that it goes on. Add all the data, you would get it as 299. So 299 is total of fx divided by n. They have already mentioned it has here 73 pages. If it is not mentioned, you need to add all this data. You would get it as 73. So 299 divided by 73, which is equal to 4.09. So therefore, the average number of mistakes per page can be considered as, even though it is 4.09, 0.09 is very less. So there won't be like half mistake or quarter mistake. So we can take it as the average mistake per pages as equal to 4. So this is how we can calculate the average when we have got the discrete data set. So similarly, suppose as the last problem, suppose we know the total average, we know the average. So in this problem, we can see here the mean is given to be 31 and we do not know, somehow this data set is missing. So we want to calculate pertaining to 50, how many times that is repeated. So that can also be calculated if we know the average. So again, since it is a discrete observation, so you can construct a column for x, you can also construct a column for f, and then multiply f into x, so that we will be getting fx. And then we know that when we are applying the direct method, the average arithmetic mean can be written as total of fx divided by n. In this problem, average x bar is given to be 31. So let us substitute that, and total of fx so would be, so except this is multiplied with variable. So leave this, add all the data. So 80, 240, 600 plus 400 plus 240, you would get it as 1560. So with this add 50x, therefore 1560 plus 50x. So similarly, in this problem, we do not know, there is one data is missing. So that missing data, you represent it as any value, x, y, a, b, whatever the variable you want to represent, you can write it in that way. Then total all the data except this x. So you would get it as 54 and then plus x, therefore 54 plus x. Then we can calculate by applying method of cross multiplication. So 54 plus x into 31 is equal to 1560 plus 50x. And then when you solve it, you would be getting the x as equal to 6. That means here the missing data. So that means here 50 is repeated 6 times. Like that, we can come to the conclusion. So just we discussed how to calculate arithmetic mean for individual observation, how to calculate arithmetic mean for discrete observation. Now let us see how we can calculate the arithmetic mean for continuous observation. What is this continuous observation? So suppose we have got decimal representation of the data. Suppose the data set is like this. Suppose again, let us take the marks scored out of 10 by the students. So some students might have, all students, suppose all students are very good. So the lowest marks is 5. So some might have got 5 and the some might have got it as, suppose it's a grading system. So 5.1, 5.2, like that is the marks. Then 5.3, then 5.5, then comes 6 or 5.7, then comes 6, then comes 6.02, like this. Okay, so you can imagine the data set now. So like this, out of 10, if you're taking, we would have a lot of data here. And then to make the calculation easily, so this can be put under the particular class. So we can put 5 to 6, how many students have scored the marks. We can take the marks under the range of 5 to 6 and F represents the frequency. Then 6 to 7, how many people have got the marks, and then we can take from mark 7 to 8, then 8 to 9, like that we can divide, we can put under the class interval. In this particular class, how many we have got scored the marks, that comes under the frequency column. So in this way we can make the data set. So this is called as continuous observations. So when we have got a continuous observation, the average arithmetic mean can be calculated as total of f into m divided by n. So here m stands for mid value of the classes, and f is the frequency of each class and n is the total frequency. So this can also be done through several methods, but here I am only discussing the direct method of finding the arithmetic mean. So let us take the example here. So this is a data set. So we want to calculate the arithmetic mean. So here 5 students have scored the marks from 0 to 10. 10 students have secured from 10 to 20. 25 students have secured the marks from 20 to 30. Like that, the data set goes on. So as the formula says, x bar can be, arithmetic mean can be calculated by total of f into m divided by n. What is m here? M is the mid value of the each class. So 0 to 10. How do you find the mid value? So you take 0 plus 10 and divide it by 2, so that you will be getting it as 5. Similarly, 10 plus 20 divided by 2, you would be getting it as 15. Like that, calculate the mid value of each classes, and number of students is given in the table. So, and then find f into m, multiply 5 into 5, you would be getting 25. 15 into 10, you would be getting it as 150. 25 into 25, 625. Similarly, multiply all the f value with the m value, and then total it, you would be getting it as 4000 divided by the number of students you would get by adding all this data, so which is 110. So this is nothing but total number of data we have considered. So then 4000 divided by 110, you would get the average marks scored by the students. Okay, so this is the average marks, 36.36. Since we are talking about the marks, it can also be written around, we can round it off as 36 is the average marks scored by the students. So let me take one more example. So in this table, we have got age of 55 patients. And then this is regarding and this is collected to study the effect of a particular medicine. We want to calculate the mean age of the patients. So 5 patients have taken the particular medicine under the age of 0 to 10. 7 patients have taken the particular medicine under the age group 10 to 20. That means 10 to 20 means it will include those people who are having the age as 10 but not 20. So it would include up to 19 but not 20. So here when we say 17 patients are under the age group of 20 to 30, that means 20, those are all having 20 ages, they are included in this data set. But if they are having 30 as their age, that would go to the next class. That particular data would go to the next class. So in this way, the data are tabulated. So we want to calculate mean age of the patients. So here we are applying the direct method of calculating the arithmetic mean. So x bar is given by total of fx divided by n, total of fx divided by n. You may say you have given in the last formula x bar as equal to total of fm, but in this case you are writing it as total of fx. It doesn't matter, it is only the abbreviation. Here x also represents the midpoint. Whether you write it as x or you write it as m, it doesn't matter. So some authors will also write it as fx, some authors will be writing it as fm, but whatever, here x represents the midpoint. So here midpoint, as I already told, how to calculate the midpoint at the lower limit and the upper limit divided by 2, you would get it as 5. So 10 plus 20 divided by 2, you will get it as 15. 20 plus 30 divided by 2, you will get it as 25. Like that it goes on. And the number of patients is given in the data. So multiply f into x. You can also call it as f into m, whatever you want to call it, because it doesn't matter. And then find the total of all the f into m values. So you would get it as 1765 divided by number of data. So it's already given 55 patients. If it is not given, you need to add all this data and then you will be getting the total number of patients. So 1765 divided by 55, you will be getting it as 32.09. That means the mean age of the patients in this group is 32.09 who has taken the particular medicine. So this is how we can calculate the arithmetic mean by direct method for individual, discrete and the continuous series.